In this video, we'll continue our discussion of section 13.3 on derivatives of multivariable functions. What we're going to focus on in this video is how to take an implicit derivative using in multivariable functions. Okay, so they want us to find the partial of z with respect to x. We treat this the same way that we would have done this in Calc 1 when taking implicit, except for now it's just a partial. So if I wanted to find with respect to x, I'm going to go ahead and take the partial of both sides. Now that should be a z. So just like we did in Calc 1, I take the derivative of both sides, but now it's just with respect to x. So I have 2xy. I want to point something out. There's this weird thing that has to happen here. Anytime we have x times z or y times z, we have to do a product rule, because z is some function of x and y. Okay, so plus, okay, now I do a product rule here. Derivative of x with respect to x is 1, so I get z. Plus, now I do with respect to z, so I'm going to get x times the partial derivative of z. Plus, now I do the product rule here. I'm actually going to show all this one of y, still bracket there, times z plus, right, and then we do z squared there. Then y times the partial derivative with respect to x of z squared. And then the partial derivative of 8 is 0. All right, let's go ahead and take all these derivatives. I'm going to move my equation over. 2xy. Okay, I get a plus z. And then times x. And then I don't know what that is, so it literally becomes just like partial implicit differentiation back in the past. This becomes the partial with respect to z of the partial with respect to x. Sorry, the partial of z with respect to x. This becomes, okay, the partial of respect of y with respect to x. That's a 0, so that term is gone. All right, that went to 0, and then the last term, okay, well, I get 2z with the derivative, so I got 2yz, and then I don't know that what z is. That's the whole point, and that still equals 0. Right, so now I'm going to get to z, the partial of z with respect to x, by getting it all on the same side. So we have the partial of z with respect to x times we have an x term and we have a 2yz term. I'm also going to move those other terms over. So we got 2xy minus z. So if I wanted to solve for the partial of z with respect to x, we'd have negative 2xy minus z all over x plus 2yz. There is my partial derivative of z with respect to x. That's how x changes with respect to z at any point. All right, we got to do the other way. So let's label that partial of z with respect to x. All right, let's do partial z with respect to y. So again, we're taking the partial. I'll try to write kind of small here because we're going to run out of space on my screen. I got x squared y plus xz plus yz squared equals the partial derivative with respect to x of 8. Not x this time, but y. Doesn't matter on that side, but let's be correct. All right, so this with respect to y now. So I have x squared, because that's just a constant. Xz is a constant, so it's gone. And then yz squared, I just get z squared. And that equals, but anytime, we have product rules. Don't make this mistake. It is so easy to make this mistake. We have to do a product rule here because it involves a z. So we can't treat it as a constant as much as we want to. We can't, because z is a function of x and y. It is very tempting. I almost just did it here. So we take the partial with respect to y of x times z plus x times the partial with respect to y of z. And then we have that partial. We have, okay, the partial of y with respect to y times z squared plus y times the partial with respect to y of z squared. And that equals 0 on the right-hand side. All right, so we get x squared right? And then we have the partial of x with respect to y. That's gone. Right? Plus, I have x. Okay, the z becomes a 1, but I get partial of z with respect to y because I don't know what z is. It has y's in it. Could. Right? The partial of y with respect to y, that's a 1. So we just get z squared. And then plus, okay, the y, the 2, I get 2yz. And then now it's the partial of z with respect to y there. Same type of thing. I have two partials of z with respect to y. So I'm going to group those together and factor it out. And then I'm going to move whatever's left, negative x squared, negative z squared, to the other side. All right, that tells me the partial with respect to z. I keep saying it wrong. Partial of z with respect to y is equal to negative x squared minus z squared over x plus 2yz. So we found a formula for the partial derivative of z with respect to x. So you can find how is x changing with respect to z, like how, right, the other way around. How is z changing with respect to x? So if z goes up and down, we could take a look and see how the x is changing back and forth. Very important. We're actually going to take this, just like in Calc 1, we're eventually going to apply this to maybe some extrema and some other things that we'll be able to gain from these partial derivatives. As of now, we're just going to get them down. So let's take a look at another one. So this is another implicit. We're going to do a setup only here just to keep video short. Also, because this is just, it's a lot of algebra. I don't think we should practice algebra in our videos. So I'm taking the partial with respect to x of both sides. Remember, if it involves a z, we have to use a product rule, regardless of the other variable. So there is our partials with respect to x. All right, so we have, that one does have an x, so we get negative 2 sine x plus 2y plus the chain rule, so it's times the derivative of the inside. So the derivative of x plus 2y is just a 1, right, with respect to x. The 2y is gone because it doesn't have an x. Plus, all right, I have to do a product rule there because of the yz. Well, if y, yeah, let's do that. So we'll do, we get cosine yz, and then it's going to be times, let me scoot this whole expression over because I've realized I'm going to need some more room. All right, so we have the product rule, so it's the derivative with respect to x of y times z plus y times the partial with respect to x of z. And then that last thing is gone, and we get 0. Okay. I like doing the product rule every time. I pause for a moment because there's a way you could just do it really quick. I think you need to go through that, especially with this, because it's so easy to overlook the product rule with the z, just like I almost did a second ago. So we get negative 2 sine x plus 2y, and then plus, okay, let's go ahead and just do everything inside that bracket. Derivative, this goes to 0, because derivative of y with respect to x is 0. Then I get y times the partial of z with respect to x. We could solve then. I'm going to stop there. We could solve. All right, let's do the partial of z with respect to y. So I do the partial of y on both sides. We're just doing setup only. You would keep going solving down for partial of z with respect to x on that last problem. All right, then we have yz minus 1 equals 0. Oh, and then we want the partial derivative with respect to y of 0. Okay, so we have a y in that first one, so we get negative 2 sine x plus 2y times the chain rule, so it's the derivative of your inside with respect to y. We just get a 2. Then we get plus, okay, we get cosine yz times, okay, it's going to be the product rule, partial with respect to y of y times z plus y times the partial with respect to y of z. And that equals 0. All right, we would work that out, and you could solve for dz d. Actually, we should do one more line. We should do all the partials. So I'm going to leave that. We get negative 4 sine x plus 2y. I'm not going to move any of that around. Plus, I get cosine of yz. And then I do my brackets. Okay, so this, neither one of these are going to turn out to be 0. I get the derivative of y with respect to y is 1, so we just get a z. Plus, okay, the derivative with respect to z is z over the partial of z with respect to y, so we get y times the partial of z with respect to y. So we'd have that equation. Now it's just algebra down to solve for d, z, dy. Same with above, right? I could move all this down. And I'm just going to leave it alone. But we could solve that above here too, right? We could solve this equation too for dz dx. All right, that's how you do implicit. It is not much different. You just have to get your product rule down. Or not product rule, the product rule with the implicit and also the partial differentiation. Does take some time. Keep at it.